Good morning, everyone. I am Dr. U. Shakti, working as Assistant Professor in Computational Intelligence Department, School of Computing, SRM Institute of Science and Technology. Today, we'll see about insertion sort. What is insertion sort? How it works? What's the algorithm for insertion sort? And how to implement insertion sort in C language? And time complexity, analysis of insertion sort, how to find time complexity and space complexity. First, we will see what is insertion sort. So sort means arranging values in ascending or descending order. Insertion, the name itself we can understand, insert the element at the correct place. You're taking the element from the unsorted list, inserting at the correct place to sort the elements. So this approach virtually splits the input array into two parts. First part is sorted array and second part is unsorted array. Sorted array contains elements in sorted order and unsorted array contains the elements in unsorted order. That is the element to be sorted. So we are splitting virtually, not actually, so virtually we are splitting the array into two parts as sorted array and unsorted array. And what's the process? What is insertion process? So from the unsorted array, take the elements one by one and place the element in the sorted array at the correct place or correct location. That is called insertion sort. So take the element from the unsorted list, insert the current element in the correct place in the sorted list. That is called insertion sort. Now we will see with examples. What is insertion operation? So virtually we are splitting the array into two parts. First half sorted array, the elements are sorted order 1, 14, 20. And second half is the blue color represents unsorted array. The elements is not in order. So we are taking the first element from the unsorted array. So the first element is 6. So the first element from the unsorted array, that is 6. That is 6 is compared with its predecessor. That is 20. 6 predecessor is 20. Now 20 is greater than 6. Current predecessor is greater than 6. So again move 20 to the next location. See the second box. 20 is moved to the fourth place. Again compare 6 and 14. Again the next second predecessor 14 is greater than the current location, current element 6. Again move 14 from second place to third place. Now compare 6 with 1. Now the current predecessor 1 is lesser than 6. Now at that time, insert 6 at the second place. Now second place is empty because 14 is already moved to the third place. Now the current predecessor 1, which is lesser than the current value. So insert 6 after the current minimum predecessor value 6. Now 1, 6, 14, 20 is in sorted order. Again, we have three elements in unsorted array. Again, we have to take the first element from the unsorted array, that is 16. So compare 16 with 20. 20 is greater. So move 20 to the next place. That is 16th place. Again, compare 16 and 14. So 14 is lesser than 16. Now insert 16 after 14. Now we have the values in sorted array. This is the process of insertion sort. So the concept is we have two part sorted array and unsorted array. Take the first element from the unsorted array. Compare it with predecessor 20. So predecessor is greater than the current value. Move predecessor value to the next location. If any one predecessor value is lesser than the current value, stop the comparison and move the current value with the current empty location. That is, we are inserting 16 at the correct place in the sorted array. That is called insertion operation. And we will see algorithm. So algorithm is a step-by-step procedure of solving problems. This is language independent. We are not following the syntax of any programming language. So algorithm name is insertion sort. The input is array. Contains n elements. Index from 1 to n. So input is array 1 to n elements. N represents number of elements in the array to be sorted. So input is array ARR. The name of the array contains n elements in unsorted order. The elements are not in order input. What's the output? After insertion sort, all the elements are sorted in ascending order. So array AR contains n elements in sorted order. That is the output. Now we will see the steps. There are 9 steps in insertion sort algorithm. So we know the concept. So we have sorted array and unsorted array. So initially take the first element, array 1. Array of 1, the first element as sorted array. So remaining 2 to n as considered as a unsorted array. Now take array of 1 as sorted array. Third step, take the values 1 by 1 from array of 2 to n. So array of 2 to n is unsorted array. The first element is array of 2. So that should be compared with its predecessor, array of 1. So the current array of 2 is assigned as current value. Here the I values vary from 2 to n. Now compare the second element, current value, with its predecessor first value. If the predecessor value is greater than the current value, move predecessor to the next location in forward direction. If the predecessor value is lesser than the current value, insert the current value in the empty location. So this process is repeated for the values I 2 to n. So after these 3 steps, repeat the step 3 to 7 till we have the elements in sorted order. So finally output the sorted array. So this is the algorithm for insertion sort. So we have sorted array, unsorted array. Take the first element from the unsorted array, compare it with predecessor. If predecessor is greater than the current value, move predecessor to the next location. Else, store the current value in the current empty location. That is the algorithm. Next, we will see how it works. Working of insertion algorithm. This is an example. So we are taking n equal to 10. 10 is number of elements in the unsorted array, input array, ARR. Here n is size of the array. And we have 3 notations. A green box represents sorted array and yellow represents the first element in the unsorted array. First element in the unsorted array. The yellow color element is we are inserting at the correct place in the sorted array. So every step we are taking yellow box, that element as current value, that is stored in a sorted array at the correct place. And the normal white box represents unsorted array. So take the first row, we have n elements 12 to 14, that is input array, unsorted array. So in the first step, we are taking first element array of 1 as sorted array. So initially we are taking first element as a sorted array, first element. Remaining 2 to n, that is 5 to 14 taken as unsorted array. Now how insertion chart works. So take the first element from the unsorted array. So unsorted array we go 5 to 14. So 5 is the first element in the unsorted array. That should be compared with its predecessor 12. Now the predecessor is greater than 5. In that case, move predecessor to the next location. That is from first to second. Okay. Now move 5 to the current first location. That is location of 12, 5. Now 5 and 12 are in sorted order. So remaining we have 3 to n. That is 17 to 14. So take the first element 17. So how to insert in the sorted array? So compare 17 with 12. Predecessor is lesser than current value. So store 17 in the same place. Okay. So now we have 5, 12, 17 is sorted order. Next remaining we have 4 to n. So again 6 is the first element in the unsorted list. So 6 should be compared with 17. So predecessor 17 is greater than the current value 6. So move 17 to the next location. That is from third place to fourth place. See the next row, you can understand. 17 is moved from third place to fourth place. Again, compare 6 with 12. Now 12 is greater than 6. Again, move 12 to next place. Again, compare 6 with 5. Now 5 is lesser than 6. Predecessor is lesser than 6. So insert 6 in the current location. That is after the minimum 6. So now 5, 6, 12, 17. The fourth row, 5, 6, 12, 17 are in sorted order. Remaining elements are called as unsorted array. So again, we are taking 8. So compare 8 with its predecessor 17. 17 is greater than 8. So move 17 to the next location. Again 12 and 8. 12 is greater than 8. So move 12 to the next location. Now compare 8 and 6. So 6 is lesser than 8. So move, store 8 in the current location. This is third place after 6. So we have 5 elements in sorted order. 5, 6, 8, 12, 17. Now remaining. So we have 1 to 14. So one yellow color is the current element from the unsorted array. Compare 1 with 17. 17 is greater than 1. Move 17 to the next location. Again compare 1 with 12. 12 is greater than 1. Again move 12 to the next location. Again compare 1 and 8. 8 is also greater than predecessor. 8 is greater than current value. Move 8 to the next location. Again 1 and 6. Move 6 to the next location. Again 5 which is greater than 1. So move 5 to the next location. Now we reach the left end. After this, no more element. So insert 1 in the initial first place. Now 1 to 17. 6 elements are sorted in order. So remaining we have only 4 elements. So 4 is the first element in the unsorted array. So compare 4 with its predecessor 17. 17 is greater than 4. Move 17 to the next location. Again, next predecessor 12. 12 is greater than 4. Move 12 to the next location. Again, take 8. 8 is greater than 4. Move 8 to the next location. Again, compare 4 and 6. 6 also greater than 4. So move 6 to the next location. Now, see 1. 1 is lesser than 4. Now insert 4 at the second place. So we have the elements from 1 to 7 in sorted order. Again we have 3 elements 2, 11, 4. So 2 yellow color is the first element in the unsorted array. That should be compared with predecessor 12. 12 is 17. 17 is greater than 2. Move 17 to the next location. Again 12 is greater than 2. 8 is greater than 2. Move 6 is greater than 2, move to the next location. Again, 5 is greater than 2, move. 4 is greater than 2, move. And then 2 is compared with 1, 1 is lesser than 2. Now insert 2 at the current place. Now we have only 2 elements, 11 and 14. So unsorted array 11 and 14. 11 is the first element. Compare 11 with 17. 17 is greater than 11. So move 17 to the next location. Again, 11 is greater than 12, move 12 to the next location. Now the predecessor 8, which is lesser than 11. So stop the process, insert 11 at the current place. So after 8, before 12, the 11 is inserted. Now we have only one element, last element 14. Compare it with predecessor 17. 17 is greater than 14. Move 17 to the next location. Again compare 14 and 12. 12 is lesser than 14. Stop the process, insert 14 at the current place. That is between 12 and 17. So this is a final sorted order using insertion sort. The general concept is array is split into two parts. Initially, we have first element in the sorted list. Remaining elements are unsorted. So take the first element from the unsorted list, compare the current element with its predecessor. That is the last element in the sorted array. If the predecessor is greater than the current value, move predecessor to the next location. If the predecessor is lesser than the current value, insert current value at the current location. So this process is repeated for values from 2 to n. So finally we have all elements in sorted ascending order. And how to implement insertion sort in C program, in C language. So normally we are using the modularity. Modularity means if the program is too large, we can divide the program into small subprograms. That is called module. Here, instead of writing complex code or more statements in one, in main function or in one module, that increase the complexity. So what we can do is we can split the program into number of modules. So we should apply modularity technique for writing program. So see here, we have int, the last int main function, that is entry of C program. So we have declared array, integer array. So here in this program, in the same example, what we discussed in the previous slide, where I am taking the same examples. The input is assigned in the program itself. So here instead of writing this line, you can get input during runtime. So you can write one more module, void accept array. Void accept array, you can add one more module. Using that array, you get n values from the user during runtime. So that is one concept. So int n equal to size of array. In this concept, we didn't declare what is n value. So automatically the size of array, it counts number of elements in the array. And the function called insertion sort, the module is called, or the subprogram function is called by passing two arguments, array and size of the array. So now see void insertions are the top, the algorithm. So the algorithm receives two inputs, array and size of the array n. So we have declared three local variables, int I comma key comma j. So we need two variables. I represents the current value and j represents to access its predecessor, j minus I minus 1, its predecessor. So we are using two variables, I and j. I for current value, j is to take its predecessor value. And what is k? K is a current, the first element in the unsorted array. There is a current value is called as key that should be selected and inserted at the correct place in the sorted order. So now key value is array of I. I value is 1. Now we are not taking array of 0. Array of 0 is called assigned as sorted array. The first element is assigned as sorted array. So from the unsorted array, the first element is 1. Array of 1, that is taken as current value. That current value is compared with its predecessor. So j represents the location of predecessor. So I is the current value. I minus 1, the previous predecessor is I minus 1, that is j. Now we are using the while loop. So there are two conditions for while loop. Two conditions should be true to execute the while loop. What are two conditions? J greater than or equal to 0. J, if j reaches the left end, that's the first element in the sorted array, we can proceed. If it should not crosses j and array of j is greater than key. Now the current value is greater than predecessor. Now the current value is greater than predecessor. Move the value to the next location. So array of j is moved to j plus 1. So we are comparing predecessor with current value. If predecessor is greater than the current value, move predecessor j to j plus 1 next location. That is moving predecessor. Now again j equal to j minus 1. So j, we are taking second predecessor in the left side. From left side it's moving. So to take immediate predecessor, next second predecessor, third predecessor, access it using the variable called j. So after this, after the while loop, the key is inserted at j plus 1. So j plus 1 is the correct place of current value to be inserted in sorted array. Now the insertion sort is an in-place sorting. All the operations are performed in array ARR. Now, after insertions, in the main function, we are calling print array. So, we are passing array comma n. So, in the print functions, we prints value from 0 to n minus 1. So, there is a print module. So, instead of assigning this first values in the program itself, we can use scan array, get the values from the user during runtime. and call insertion function and print functions. So finally, output, we are getting all the values in ascending order. So this is the implementation of insertion sort in C language. Next, we will see analysis of insertion sort. So, what approach we are applying in insertion sort? This is an iterative approach. What's iterative? We are using for loop. This is iterations. We are taking the element one by one using for loop. That is called iterations. Iterative approach. Iterative means the insertion sort algorithm uses a loop to iterate through the array and insert each element into a correct position in the sorted part of array. That is the iterative process. And what are the characteristics of an insertion sort? So insertion sort is very simple algorithm, very simple implementation. So this it can be efficient only for small data values, for small value of n. If the input size is very small, if number of elements to be sorted is very small, we can go for insertion sort. It is efficient. Insertion sort is not efficient for larger data values. Here, insertion sort is adaptive in nature. So it is appropriate for data sets that are already partially sorted. If the input is partially sorted, insertion sort is adaptive or can be easy to implement. And insertion sort is in place sorting. In place means all the operations are performed in the same input array ARR. We are not using additional array to store and sort. So all the operations, sorting operations are performed in the same array AR itself. These are the characteristics of insertion sort algorithm and time complexity of insertion sort. There are two complexity, time complexity and space complexity. Time complexity means how much time algorithm takes to sort the values, that is called time complexity. And space complexity is how much memory it occupies to implement insertion sort is called space complexity. Normally, we are not bothering about space complexity. Here, the time complexity. So there are three cases: worst case, average case, and best case. So worst case is if the input is in descending order. So all the values are moved and swapped. So in that case, time complexity is order of n square, quadratic. The average time complexity also order of n square. The best case, what's the best case? If the input is already in sorted order. The input is already in sorted order. So we are taking current value, comparing with this immediate predecessor, that's all. So it performs only n comparisons. So in the best case, time complexity is order of n. Worst case and average case, time complexity is order of n square. Here the space complexity does not require any extra array or memory locations. This is in place sorting algorithm. So it needs only one array. That is enough. That is the time complexity of insertion sort. Normally, insertion sort time complexity is order of n square. Thank you.